So the problem that gave me the most trouble was actually the first problem. So it gives you a two resistors connected in parallel. They're connected with two batteries, each with an EMF and two pieces of nichrome wire. And N, U are both constant. The first wire has a length L1, the second wire has a length L2, and the radius of L1 is twice of the radius of L2. And they're all connected, so something I didn't get any points on was write down all the possible loop rules and a node rule for node 1 and node 2. So basically what you want to do is take into account that delta V is equal to 0, which is the loop rule. So we have 2 times our electromagnetic force, and we subtract the electric field of 1 times the length of the first wire, and subtract the electric field of the second wire times the length of it. But what I did not do correctly was identify that there are 2 separate currents running through the 2 resistors in parallel, which gives us an IL and an IR, which it's an either or situation. Only one can be taken into account because they're in parallel. So we know that they're equal to each other. So these separate equations are like that. We also need to recognize that the first convectional current is equal to the second one. That's our node rule, because the current before one node has to equal the current of another node. And we have to know that the current I2 that's going through the 2 resistors in parallel must be equivalent to the sum of both of those currents. So that is what I did wrong. That's the loop rule, that's the node rule. I hope you don't miss it. Thanks for watching.